everyone, welcome back to my channel. This is a video related to our inorganic chemistry, that is group number 2. So we are going to discuss today in this video the reaction of the alkali earth metals with acids. So here we are going to discuss two main acids. One is the hydrochloric acid, other one is the sulfuric acid. So same goes with the nitric acid as well, but we are going to discuss these two only. One thing you need to remember that we have learned already, or if you haven't, then I'll describe it, that all chlorides are soluble. So when we write the state symbols with equations, you need to keep this in mind that all chlorides are soluble. So those should be written as aqueous. So it's not hard to learn the solubility table. It's quite easy. We say all chlorides are soluble, all sodium salts are soluble, or potassium are soluble, or nitrates are soluble. Sulfates are not soluble, only few are soluble. So when we react these alkaline earth metals with sulfuric acid, sulfates are formed. So only magnesium will be soluble, otherwise the other are not going to be soluble. Those would be written as solids. Keep this thing in mind. Then you must know that carbonates are not soluble except the sodium one, potassium one. These one are soluble, definitely. Ammonium is soluble. So you must know a few points related to the solubility table in order to write the state symbol, as it was asked by many students that how do we know how whether it is to write solid, whether to write aqueous, whether to write liquid, whether to write gas. So you must know the basics of chemistry. Like we discussed that metals are solid, so usually with metals we write S. Then water we write liquid. Definitely it's we are not going to write any other state, except if we are writing reaction with steam, then we write G, not L. Keep this thing in mind. Then gases like oxygen, carbon dioxide, these are gases. So you have to mention G with these one. And when we talk about salts, especially, the salts would be written according to their solubility, whether they are soluble or insoluble. Let's move to the reaction. So when we write the reaction with acids, keep this in mind. When hydrochloric acid is allowed to react with the group 2 elements, they react vigorously, producing the hydrogen gas. Okay, why hydrogen gas? So we have, for example, HCl. It is going to produce two ions. One is the hydrogen ion, other is the chloride ion. If we talk about the group 2, the group 2 act as a dipositive atom. So definitely it is going to it is going to attract the negative ion, or it is attracted toward the negative ion, uh, rather than the positive ion. So definitely a salt is formed, that is halide is formed instead of hydride. So you must know the basic logic behind every reaction, and it's really easy to remember. So when they react with sulfuric acid, the reaction is same, the vigorous reaction is going to occur. But keep in mind that there are certain sulfates which are not soluble, like calcium sulfate is not soluble, strontium sulfate is not soluble, barium sulfate is not soluble. So those actually it seems like that the reaction stop after a certain time. So the reaction is slow due to the formation of sparingly soluble calcium sulfate layer that coats the surface and block hydrogen bubbles. So it seems that the reaction has stopped, so because of the formation of a layer is outside it. Same goes with strontium and barium. The reaction stopped quickly. Why? Because a layer of insoluble sulfate is formed outside, uh, and it's and there is no release of hydrogen bubbles. So the key point that you need to remember is the decreasing solubility of group number 2 sulfates decreases down the group because of the reaction that is happening really slow, or it happens that the reaction stop because of the formation of the outer layer. So while if we talk about the hydrochloric acid, the reaction is quite you can say vigorous. When we move down the group, the reaction is not going to be like slow. Why? Because the salts that are formed with the reaction with hydrochloric acid are all soluble, and there is no formation of a hard layer outside, or there is no formation of any solid. That's why the reaction is quite easy or feasible with the hydrochloric acid. Let's move to the reaction. Let's discuss each reaction. Discuss reactions of these metals with hydrochloric acid. So first of all, we write the general equation. We say that these metals react with HCl, forming metal chloride along with hydrogen gas. Let's just balance it and write the state symbol. It would be S, it would be aqueous because we are talking about the dilute hydrochloric acid. So we discussed that all chlorides are soluble. So keep in mind all chlorides are soluble. So we write here the aqueous, and this hydrogen gas is gas, hydrogen is gas. So you can, if you carry out a reaction, because you might carry out these reactions and you are going to uh, perform this in lab, and you'll observe that bubbles are going to produce, and sometimes you need to have the volume of that hydrogen gas for certain experiments. So you have to use the syringe or a volumetric cylinder in which you can keep your gases to have a correct volume. So this is the general reaction. Now just replace M with any of the metal of group number 2. Let's just write starting with the with magnesium. Magnesium react with, sorry, it's a solid, sulfuric acid, oh sorry, hydrochloric acid, that is dilute, so we write aqueous. So magnesium chloride is going to form, sorry, it's an arrow over here, MgCl2 with aqueous and hydrogen gas. The reaction is quite easy. You just need to know that what are the ions produced by a certain substance. Like water, it produces hydrogen and hydroxide. When we talk about the acid, it produces hydrogen ions and the chloride ions. So definitely the negative one are going to move toward the positive one. Simple. Just just keep this thing in mind. Now let's react with calcium. The same reaction will occur. It gives CaCl2, again a calcium salt, which is soluble one. Let's discuss the barium one. You can write any, you can write strontium here as well. You can write radium as well. But for radium, we have to sometimes it has been asked in the question in the past in the papers that how do radium is going to react, because that is not given in like many courses. So you just need to predict according to these general equations. You just have to give the prediction that this salt is going to form or this compound is going to form. Simple. And if you want to know in detail, you have to watch the video related to radium. So where were we? So barium as a solid reacts with dilute hydrochloric acid, right, aqueous over here. It forms barium chloride. That would be aqueous and hydrogen gas. Simple. It's not that hard. It's quite simple. Just learn the general equation and you are going to ace it. That how to do it. Now, when we talk about sulfuric acid, again, a hydrogen ion is formed along with sulfate ion. Simple. So definitely a metal is going to be attracted toward this sulfate ion. So a metal sulfate is going to form. Let's write the general equation. It is M. It reacts with H2SO4. It would be solid, it would be aqueous because these are dilute acids, and MSO4 because it is plus 2 and it is minus 2. So we are not going to write here 2 or 2 here, nowhere. So along with the hydrogen gas, okay. So it depends upon the solubility. Like if you talk about the magnesium, that is soluble. So magnesium, for magnesium sulfate you are going to write aqueous. For barium sulfate it is not soluble, you write S. For calcium sulfate same, you write S. And for strontium sulfate you are going to write S. So this for here you need to remember the solubility rule. Simple. So let's just write the equations for any of the element. For example, magnesium. Magnesium, it reacts with sulfuric acid. Let's write the state symbols. It would be solid, it would be aqueous, and it gives magnesium sulfate, and magnesium sulfate is soluble, and hydrogen as a gas. Okay, it's quite simple. There is no balancing required, it's already balanced. Let's write for barium. It's Ba, solid plus H2SO4. For barium, strontium, calcium, it's same. Aqueous, it gives barium sulfate, BaSO4. That would be solid, and it would be present at gas. So first thing, you should know the general equation. Second thing, you must know the solubility rule, and you can perform, like, you can write any equation or do any reaction or write the equation for any reaction of dilute sulfuric acid with any of the element of group number 2. Simple. So for more reactions or for more chemical properties, you need to move to another videos. So see you there.